What up, calculus students? Mr. Messer coming at you from our house with special guest appearance.
Lola?
Yeah, I would say hi to the calculus students.
Hello?
When you were young during COVID, we used to like sit here all the time
Oh.
and you'd be like drawing. And I'm like, Lola, say hi to the calc students. You're like, hello, calc students. So it's pretty funny. So this is like a good throwback here. We are going to talk about and introduce the math of change, Lola. So if I asked you how much change occurred to take the number 3 and turn it into the number 15, what would you say? 3 to 15, what's the change to get from 3 to 15?
15. I mean, 10. 12.
Good. 12. And how did you figure that out?
I did 3 to 10, and then add the 5 and add those two numbers.
Cool. So you kind of like said plus 7 plus 5, and that's 12. My thing is supposed to be showing up, but it's not showing up. So we gotta give it a couple seconds. There we go. All right. So plus 12 is correct. Now, what's another thing we could have done is actually subtract the two numbers. To figure out how much we're adding, you can subtract. So we subtract to find the net change. So what's the change from 5 to 9?
Well, I take away 5 from 9, and that'd be 4.
Great. So you just did it the other way, which is to do the subtraction. And you can see that like from 5 to 9, you add 4, right? So we didn't have to do the subtraction. We can kind of just see the plus 12. We can kind of just see the plus 4. Cool. Well, now, have you ever seen graphs yet?
No.
Well, graphs are
I'm not
like
going to see it
this.
the entire year.
Yeah, you're not going to see graphs for a while, but I got your back. Graphs have context. So here is the point 1, 3, 1, 3, and here's the point 7, 15. So there's like an x that goes with this y. So here's the number 3, but it goes with the x of 1. Here's the number 15 that goes with the x 7. And we can still see that from 3 to 15, you are still adding 12. So we still have the idea of the plus 12. But there is some context because there was some like horizontal distance here to go from 1 to 7. So how far is 1 and 7? What's the change from 1 to 7?
The change from 1 to 7 is 6.
Good. So we have a change in our y's and a change in the x. And the way we can kind of
Still won't get the y and the x bit.
don't worry about it. The way we can kind of combine the two changes into one thing is to divide. And what we realized is we just found slope. And slope is what we're going to do to find change. It's really the key to this entire class. We get an answer of 2. Now, what's 2?
Is it an elementary thing?
No.
Seems more like an elementary thing.
I know. I try to teach so that even elementary school students can understand.
Kind of understanding this.
So slope is the y change divided by the x change, simplified to be 2 y's per x.
You could teach this to the 5th graders and they'll probably understand.
Yeah, maybe 5th graders will understand. Versus here, how much is the change from 2 to 3 for our x's?
Change from 2 to 3 is 1.
Cool. And all of a sudden, we see that like with some context, we might answer differently who had the more change. So I realized that what we could do is we connect 2 points of a line, and it's the slope of this line that will tell us an average rate of change. An average, like go up this many y's per x, and you will travel from this point to that point, which is showing you on average how the function is changing. Okay? So don't worry, slope equals change. Cool? Great.
Okay.
So I found the slope of that line segment was 2. I would say on average, my function is Would you say the function's going up or down? Would you say we're increasing or do you say we're decreasing?
We're increasing.
Yeah, so you can kind of see that it's going up, and we like to look at things from left to right. Thank you, United States of America, for reading things from left to right. On average, the function is increasing 2 y's per x, but over the interval 1 to 7. Cool.
Cool.
All right. And we found this line between this point 2,5 and 3,9. We said that the y's increased by 4 as the x's increased by 1. We found the slope of this line was 4. Well, now we can say, on average, if you increase 4 y's per x, starting at what?
Learning about comparison between numbers right now.
Okay,
It's
so
not as fun.
well, which one's bigger? 4 or 2? Yeah, so good. You're comparing. Now, here the next one is going to be a little bit trickier because we're going to go from this point 2,5 to 6,0. Okay, so Lola, 5 to 0, what's the change?
5 to 0. The change would be 5.
Yes, but I would say I went down 5, right?
Mm-hmm.
So I'm going to use this negative symbol to kind of denote that I went down 5. Okay? You can also use the slope formula, everybody out there.
The same thing about
Oh, the worst. Bug bites. We have bugs living in our house. And what about 2 to 6?
Let's do the same before.
Cool. So 5 to 0, I would say we subtract 5 instead of like add 4. We subtract 5, but 2 to 6, I'd say we add 4. So I find that this slope is 5/4, but it's negative because I'm subtracting. Now, this is where you guys might be different.
This daytime, I'd be writing this down right now.
Nah, you're fine. What I want my students to do is like pay attention and not just copy down while not thinking. You know, we want to think while we're learning, not just copy things down. So if we told students, hey, how would you interpret that? Many students would say the function is decreasing 5 y's per x. They'd say it's decreasing because we're
Is there an
subtracting.
imaginary camera right there?
It's up there.
Oh.
But here's key. We would say on average, my function is decreasing, and here's what we're going to do. We're going to make this a y's per x just by putting this number over 1. Yes, it's a fraction, but a fraction is just like a number that's negative 1.25 over 1. So we're going to decrease 5/4 of a y per x.
Why are you talking so loud?
Because, I don't know, on the interval from 2 to 6. Okay, so what did we learn? How do we find how things are changing?
Huh?
How do we find out things are changing? Numbers. How do we find out how numbers are changing?
We just look at the numbers and they're changing.
We look at the difference between the numbers, and if we have context, we find the context, we divide to have one kind of rate of change in terms of y's per x. We'll call this an average rate of change, or A rate. Y's per x, how quickly a function is increasing or decreasing on average over an interval. Okay? On average over an interval. Cool. Now, if I have a function like x squared, what would I need to do? Well, if I'm asked to find the average rate of change, it's like take the value and square it.
What's x squared?
What's 1 squared?
Like,
What's 1 as a square?
1 is squares 1,
What's 4 as a square?
2,
No. What's 4 as a square?
4.
No. What's 4 as a square? 4 fours.
Oh, 16.
Cool. Right. So if you're asked to find the average rate of change, and this is really the lesson, if you're asked to find the average rate of change, you should be thinking slope and slope formula. You should be like, hey, let's find the increase of the x's, the y's, increase of the x's. I'm not going to use the slope formula because I know from 1 to 16, what do we have? What kind of change?
15.
Cool. And then from 1 to 4, what kind of change?
3.
Yeah, so I'm using the slope formula right here. My y's increased by 15, my x's increased by 3. I have 5. I would say on average, this function, this graph is increasing. On average, f of x is increasing 5 y's per x over the interval from 1 to 4. All right, now let's do some fractions. For j,
Hey.
from 1 to 4, we're finding the average rate of change. Make sure we understand these are x's. All we need is the 2 points. What's 1 split into 1? What's 1 times 1? How about that? What's 1?
1.
1. Good. 1 divided into 1 piece is also 1. What is 1 divided into 4 pieces?
1 divided into 4 pieces is 1/4.
1/4. Good. Now, if you go from 1 to 1/4, what's the change?
2/4.
Close. Think about 1 being a big pizza. Cut it into fourths. How many do we have?
2/4.
No. If you have one whole pizza cut into fourths, how many fourths would you have in your whole
4.
pizza? 4. So we got 4/4. But I all of a sudden get only 1/4 of a pizza left.
That's 1/3.
No. I start with 4/4. Let me write this down here. Watch. Here is my pizza. It's got 4/4. But this is just one of those fourths. What was the change from these 4/4 to this 1/4?
1/4.
I went from 4/4 to 1/4. How many fourths disappeared?
3.
So
3/4.
3/4 is my change. And do we add 3/4 or subtract 3/4?
Subtract.
Cool. What about from 1 to 4? What's the change?
You subtract
Oh, just tell me 1 to 4. What's the change?
3.
Yeah, plus 3. Or 4 minus 1 is 3. Cool. Well, here are my y's
Put the script
over my x's. And that can be simplified to be this, which can be simplified to be
This is puzzling
that.
me.
Don't worry about it. We could say on average, my function, j of x, is decreasing 1/4 of a y per x. Why do we like to say 1/4 of a y per x instead of 1 y per 4 x's? Because it's comparable. We're allowed to compare that number with all the other numbers as long as it's a y's per x. Cool? All right, you like to go back to reading?
Okay, this is interesting.
All right, cool. So, letting you know that the cosine of 0 is 1. We'll talk about trigonometry when you're older. Cosine of pi is...
trigonometry?
Don't worry about it. What's the change from...
Geometry?
No. What's the change from 1 to -1? It's like the study of like right triangles.
1.
1 to -1.
1.
No.
Zero.
1 minus 1 is 0. I need to go past 0 to -1. We haven't even gotten to negative numbers, but you're going to get there soon.
-1.
It's -2. So I go to 0 and then -1. Think about a number line. Here's 1, here's 0. This would be -1. So I subtract 2.
Okay.
Cool? All right. Now from 0 to the number pi, do you know about pi?
No.
You love pi. I'm adding pi. We would
Especially
say
pumpkin pie.
the slope is 2 over pi. Notice I'm not using the slope formula here, guys, because like too many of you guys mess up when you do it. You can if you want to. y2 minus y1 over x2 minus x1. But it's not necessary if you just understand change. Can be calculated multiple ways. I would say on average, g of x is decreasing 2 over pi y's per x. Well, what's 2 over pi? Don't worry about it. It's like close to 2/3 because pi is close to 3. So it is just a value that you can think about. It's close to 2/3. And on average, that function is decreasing.
Augusta National Symphony Orchestra.
Yep.
That was right there.
All right. If I give you a table of values, just remember that we have x's on the top and y's on the bottom. So what's the average rate of change over the entire interval? I would want you to find the average rate of change from 0 8 to 10, 0. You can use the slope formula if you want to. Just make sure you're doing it correctly. That's a subtract of 8 over 10, but I like to just go 8 to 0 is minus 8, 0 to 10 is plus 10. Okay, so y's per x, make sure you put that. That's negative 4/5. So on average, that function is decreasing 4/5 of a y per x. When are the average rate of change negative and a half? Well, you might have to do some investigation, and you can find that from the x value 5 to the x value 7. These are x's. An interval from 5 to 7, we are decreasing 1 over 2. When are we changing the fastest? We might have to look a little bit more. We think, 8 to 2, that's a big change. That's subtract 6 over 4 x's, though. That's only down 3.5. That's 1.5. But look from 2 to 5. From 2 to 5, we are increasing 3 over 1. And all of a sudden, we would say that even though the net change is bigger, the rate of change with the x's and the y's being considered would be from 4 to 5, because that's how we can compare. We have minus 6 over 4 versus plus 3 over 1. I would say that's like a bigger absolute value number. Cool. Well, now we get into some tough stuff. If you understand that, guys, that's pretty much the lesson. That's the important stuff. Is can you use the slope formula? Do you understand the interpretation? But what we're about to do now is going to transition into the next unit, where we're going to talk about more change. We're going to talk about change in functions, but not over an interval, but at a point.
Okay.
How's the function changing at a point? And what's going to help us next unit is what we're about to discover here, which is, here's a question. What if I gave you the function x squared and I asked you for all of the changes over the intervals?
Oh, cool.
Like, for example, from 2 to 21. Well, I need to know what 21 squared is. Do you know what 21 squared is?
No.
Yeah, and I don't have a calculator right now, so that's tough. I do know that 2 squared is 4, but I have no idea what 21 squared is. So this one I can't really do unless I had more time. This one's going to be annoying. This one's going to be annoying. This one's fine. F of negative 3 is 9 and f of 5 is 25.
If you go down, I can say it'd be annoying.
From 9 to 25, what's the change?
9 to 25.
Yeah.
9 minus 25 is 16.
Cool. And then what about negative 3 to 5? Think about your number line. Negative 3, negative 2, negative 1, 0. 1, 2, 3, 4, 5. What's the change from negative 3 all the way to 5?
9.
No. 8. Negative 3 to 0 and 0 to 5. 5, 6, 7, 8. Okay. All right, so that slope is 2. We got that. But the other ones are going to be tricky, and it would be annoying, and it would take me a long, long time. Well, we are going to investigate.
It can take a while. Be annoying.
Yeah, you see that? It'd take a while and be annoying. We're going to investigate the creation of a rate of change formula. And here's and here's what we got. We got x squared, and I'm going to be a little bit more theoretical. I'm going to say we are starting at a value x, and we are going to find the slope between this value x and this value at x plus h. I'm going to add a distance of h. Now, if I have this value x, I know this point on this graph would be x comma x squared. If I have x plus h, I'd have x plus h comma x plus h squared. Cool. And I'm going to use the slope formula. So I'm just going to use y2 minus y1 over x2 minus x1. I think I need some space now, unless you want to slide it. That's perfect. So I would, however, be using these x's and these h's. And I got y2 minus y1 over x2 minus x1. Oh, well, here's a formula. I just created it, but I know I can simplify it. Cool, the x's go away, and this would be the average rate of change of x squared from x to a point h distance away from x. At h, x distance away from x. But I feel like I could do better, so I'm going to. I'm going to go ahead and like distribute some stuff and simplify. Because I know that x plus h squared is x squared plus 2xh plus h squared. And then what I realize is these x squareds will go away, which is very interesting. I realize that both of these terms have an h that can be factored out. I'm going to factor out the h, and then I realize that I can divide the top and bottom by an h, and I get a equation that's very, very easy to use, that the average rate of change of the function x squared from x to a point h distance away from x is just going to be 2x plus h. Cool, so we just have to understand what x is, and we have to understand what h is, and we can find the average rate of change of x squared. Let's take a look at this. So I would say for x squared, the average rate of change is equal to 2x plus h. Well, what is x for our situation? It's our starting point. So our starting point was -3. What was h? It's really the x distance, this interval's distance. So h would be from -3 to 5, which would be 8. Okay, well, let's plug in -3 and 8 into this formula. So average rate of change from x equals -3 to, with h being 8, I'd have 2 times -3 plus 8. And what do I get? 2. I just get a 2 completely different way, not really using the slope formula. It's like I already used the slope formula to generate this equation. And what's going to be really helpful is like, look at this situation. Our x is going to be at 2. My h is going to be 19. So I can find my rate of change very easily using the rate of change formula, which would be 4 plus 19, and that's 23. Now we could double check if we had a calculator. Do you have a calculator?
No.
Whatever.
Why would I?
I don't know. We could ask Alexa what 21 squared is. But what we realize is having a formula when needed for so much calculations is actually very helpful. Here, h is -3, x is -3, h is 15. So I would get -6 plus 15, and that's going to be 9. So like cool numbers, and I actually could check this. F of -3 is 9, f of 12 is 144. I do know that 12 squared is 144. 9 to 144 is 135 over 15. Yeah, it turns out that's 9. You know, like formulas are helpful. Cool. But we're going to see very quickly that after x squared, they become more like pretty complicated to produce and very complicated to use. We're going to practice using it, and we are going to be comfortable with the idea of having a slope formula of any function between x and a point x distance away. We'll have x comma f of x as one of the points, and then the other point will be x plus h comma f of x plus h. Cool? And we'll just use the slope formula of this. Then x plus h minus x is just going to be the distance h. This is a quick formula for the average rate of change of any function with 2 points, 1 point x, 1 point h distance away from x. Cool. Now, let's do x cubed. Well, the problem is, if you're going to think about x cubed, you got to think about
What's cubed?
So, like, what's 3 3 3s?
Oh.
What is 3 3 3s?
What is 3 3s? 9?
What?
8?
No.
That's 2 2 2.
3 3s. 8 is 2 2 2s. Very good. What's 3 3 3s? It's really like 3 by 3 by 3. 3 times 3 times 3. That's what cubing is. Multiplying 3 times. So what's 3 3 3s? What's 3 times 3 times 3?
3 times 3 is 6 times 2.
Not correct. What's 3 3s?
3 3s.
Okay, 3 3s is 9 times 3. What are 3 9s?
9 times 3 is 18.
No. 6 times 3 is 18. What's 9 times 3?
9 times 3. What the heck is this trick?
If you've forgotten all of your
27.
multiplication facts,
Maybe.
we need to get you back into your math games, kid. All right, so
Our teacher doesn't let us do it. It's true.
don't blame her. You can do it at home.
My computer isn't charged.
You need to get back to your math facts. I can't believe you forgot 9 times 3. It's okay.
Oh yeah, it's 27.
Oh yeah. Okay, so let's do 4 fours.
16.
What's 16 times 4? Figure that out.
What is 16 times 4? What an interesting. Well, 40. All I have to do is 40 times 24. 40 plus 24. 64.
Nice. Very good, kid. You got it.
Yes!
That's really good. I didn't think you were going to get that, and I was okay with that. So, 4 cubed is 64. 4 4s, 64. Cool. Here's the problem with what we're talking about. Once we get past x squared, it gets more difficult. Let's look at x cubed. Well, what's x plus h cubed? I would love to stop here, but we need to go on. And this is where maybe understanding the binomial theorem and Pascal's triangle could help. Where does it come from? Well, x plus h to the 0 is 1. I'm going to just put a 1 right here. X plus h to the first is just 1x plus 1h, right? Cool, so I'm going to put a 1 here and a 1 here. What's x plus h squared? Well, we did it. You might have to do it yourself. We have 2x, we have an x squared, we have 2xh's, and we have an h squared. Now notice that the x are going down until they disappear. Meanwhile, the h's are gone, and then they start showing up. But I can see I have a 1 and a 2 and a 1. Well, what's x plus h cubed? If you were to do it out by hand, it takes a little bit of time. But you can kind of see, like, we'll distribute the x to everything, and you get this, this, this. Then if you distribute the h to everything, you get this, this, and this. And if you combine your like terms, this is 3x squared h's, this is 3xh squareds. You realize you have 1 x cubed, 3 x squared h's, 3 xh squareds, and then 1 h cubed. And that actually is helpful moving beyond that. If I wanted to go to x plus h to the 4th, well, I could use Pascal's triangle to realize it's going to be 1, 4, 6, 4, 1. But what's going to be the key is that my x's are going to start at x to the 4th. Then I'll have x cubed, x squared, x, and then the x's are gone. Meanwhile, the h's will be gone, but then they'll start showing up. H squared, h cubed, h to the 4th. Okay, so Pascal's triangle actually helps us so that we don't have to do all the work by hand, where we find the average rate of change is x cubed, or sorry, the x plus h cubed is x cubed plus 3x squared h plus 3xh squared plus h cubed minus x cubed all over h. So I did the distribution, but I still have the minus x cubed, and I have this all over h. Now, automatically, like, creating this formula is becoming cumbersome. Automatically, we had to do more work, and we get...
Dad, give me another one.
I mean, you want to try 5s? 5 cubed?
No, I mean another multiplication.
6 7s.
42.
Good. 5 9s.
45.
Good. 6/7. Did you hear that? 6/7. You should have said that. I set that up for you. You gotta spike it. 6/7.
42.
Yeah, good. I hope everybody knows that these days. Okay, now
Everybody does.
we get this. Now, automatically, this formula is not as nice as the x squared formula because I got 3x squared, I got 3xh, and I got h squared. Now, let's say I wanted you to find just the average rate of change of x cubed from 1 to 4. Well, I know that 1 cubed is 1, and Lola told us that 4 cubed is 64. It is so easy to just use the slope formula or just look at the net change of your y's and your x's and to divide them. And you got 63 divided by 3, which is 21. Cool? But you could use your average rate of change formula. You could say your average rate of change is 3x squared plus 3xh plus h squared. And you could say, all right, when x is 1, and then from 1 to 4, that h is 3, that x distance is 3. Let's see, plugging in 1, we'd have, my thing is going really slow, 3 times 1 squared plus 3 times 1 times 3 plus 3 squared. So I got 9 plus 9 plus 3. What's 9 plus 9 plus 3?
9 plus 9 plus 3. Well, 9 plus 9 is 18. 18 plus 3 is 22.
Oh, look at that. It's the same value that I found. This is where I'm trying to go. Like, equations can be helpful, but for an average rate of change, it seems like it's a little not super helpful. I would probably rather just plug in -2, cube it, -8, plug in 1, cube it, get 1. I probably would rather see that I am increasing 9 over the course of 3 x's, so the slope is 3, so the average rate of change is 3. Over this interval, on average, we're increasing 3 miles per x. But let's use the formula. If I plugged in -2 for x and an h of 3, let's use the formula. I'd have 3 times -2 squared, which is 4, plus 3 times -2 times 3, plus 3 squared, which is 9. And let's see, 12 plus, this is going to be -18 plus 9. Well, this is -6. -6 plus 9 is 3. Oh, look at that. We got the same answer. Would I ask you to do this in the real world or for the AP test? No. But I want you to know that it's there. I want you to know that it's there. So, like, if, and I'm just going to show this last time. If you look at x to the 4th, poof, it's not fun. Because you'll have x plus h to the 4th minus x to the 4th over h. Cool? I mean, that's easy to write down. But, like, I would rather probably just do 1 to the 4th is 1. What's 4 to the 4th? That's tough. What's 64 times 4?
I don't know.
Let's look this up. Actually, this is where.
Daddy's using a calculator.
It's okay, 256.
I knew.
Oh, you didn't know that. Give me a break. So I'm increasing 255
I knew it 'cause it was-
over the course of
that-
3.
Because
What's 255 divided by 3?
Blah, 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 blah.
85. That's crazy. Slope is 85. Now, like, that was hard for everything. But, like, pretty doable. This is definitely doable. What's 2 times 2 times 2 times 2? 2, 4, 8, 16. This one's easy. I'll probably do this one in class tomorrow. I'm going down 15 as I'm going over 3. My slope is -5. On average, this function, x to the fourth, is decreasing 5y's per x over the interval from -2 to 1. Cool. Let's get this -5 using the average rate of change formula. Well, we have to first distribute this. This is x to the fourth. Now, do you have to distribute this? No, but I want you to for purposes of what we're going to see in the future. We'll have 4 x cubed h's. We'll have 6 x squared h squareds. We'll have 4 x h cubes. We'll have 1 h to the fourth. That's going to be minus an x to the fourth all over h. We see that the x to the fourths will go away.
What's a pistol?
It's a gun.
What type of gun?
Like a handgun.
Oh.
Like not a big gun. After factoring out an h, we see I got a 4x cubed just sitting by its lonesome, and all the other ones have an h. Well, I can see that the h's are going to cancel. I can then say, oh, here's my average rate of change of x to the fourth. Oh my goodness, I don't want to use this. It's very, very long and complicated. 4x cubed plus 6x squared h plus 4xh squared plus h cubed. Ugh! But let's do it at least once, just so you can see that it works. When x is -2 and h is 3. Okay, so I got -2 cubed, which is -8 times 4, which is -32. I got 6 times 4 times 3. 24 times 3. 72. Okay. 4 times 2, -2 is -8 times 9. Okay. That's -72. Okay, that's nice. This is 27 h cubed. Okay, at least the 72s go away. I just have -32 plus 27. Guess what that is? -5. You can see at the end of the lesson, I say, if you were given an option, plug in x's, get y's, use the slope formula, or generate an average rate of change equation using this, and then plug in your x's, your h's, which one would you choose? I hope you would say this one. Okay? But what I'm going to show you starting next unit, because we're going to start talking about the D word, which is derivatives. These formulas actually are going to be extremely useful in all situations. And I'll show you why. Okay? So, for the lesson, I want you to understand that slope equals change. The slope of a secant, or the slope connecting 2 points, gives you an average rate of change. We say on average, a function is increasing or decreasing. This many y's per x lets you compare rates of change over intervals. Okay? That's it. Time to go to bed. Peace.